On the same day, on the exact same day. In a country roughly the size of the state of Oregon, one half was digging out from under a May blizzard, while the other half was lying in the warmest spring sunshine in years. Children in Yorkshire were building snowmen, while children in Cornwall were on the beach. Roads in the north were closed by drifts. Gardens in the south were blooming. No natural disasters, no volcanic eruption, no unusual cosmic event. Just Britain in 2026, doing what Britain increasingly does, experiencing two completely different climates simultaneously, in a pattern that scientists have now given a name. They call it climate whiplash. And what happened across the UK that day was one of the most dramatic examples of it ever recorded in a single 24-hour window. To understand how a country can be snowbound and sunburnt at the same time, you need to understand the single most important piece of atmospheric machinery that controls Britain's weather. It is called the jet stream. It is invisible. Most people have never thought about it. And yet it is the reason Britain gets the weather it gets, when it gets it, in the intensity it gets it. The jet stream is a ribbon of extremely fast-moving air flowing west to east high in the upper atmosphere, roughly 7 to 12 kilometers above the surface of the Earth. It is not a gentle breeze. At its core, winds inside the jet stream can exceed 300 kilometers per hour. It circles the entire northern hemisphere, and its position relative to the UK on any given day is probably the single biggest factor in determining what kind of weather is coming. When the jet stream flows in a straight, fast band well to the north of the UK, high pressure settles over Britain, and the weather is calm, warm, and dry. When the jet stream dips south and runs directly over the UK, it acts like a motorway for Atlantic storm systems, pulling in low pressure, cloud, wind, and rain in rapid succession. And when the jet stream meanders, slows, and develops large waves, looping far north and then plunging sharply south, it can create something that meteorologists have been seeing with increasing frequency in recent years. It can split the country in half, putting one region under the descending warm air of a ridge and another region under the ascending cold air of a trough at exactly the same time. That is precisely what happened. A large blocking high-pressure system had parked itself over the near continent and the southern parts of England, drawing up warm southerly air from France and the Iberian Peninsula. Temperatures across the south and southwest climbed into the low to mid-20s. London recorded 23.8 degrees Celsius. Parts of Kent and Sussex touched 24 degrees. The air was the kind of warm, still golden air that the British summer promises, but rarely delivers quite so early in the year. People were in parks. Restaurant terraces were packed. It felt like June. Meanwhile, on the other side of that same weather pattern, a deep, low-pressure system had funneled cold Arctic air southward over Scotland and the north of England. The temperature contrast between that cold northern air mass and the warm southern air was sharp enough to sustain precipitation, not as rain, but as snow. Heavy, wet, sustained May snow of a kind that even hardened meteorologists described as genuinely unusual for the time of year. Over the Pennines and the Yorkshire Dales, accumulations reached 20 centimeters. Passes were blocked. Wind gusts on exposed hilltops measured over 90 kilometers per hour. The combination of snow and wind produced whiteout conditions that the Met Office designated as a rare amber weather warning for a month, in which such warnings are almost never issued. 18 counties across northern England and parts of the Scottish borders fell within the snow warning zone. The disruption was immediate and significant. The A66 Trans-Pennine route, one of the key east-west links across northern England, was closed for over 12 hours. Dozens of schools canceled in-person learning. Gridding teams that had been stood down for spring were recalled overnight on emergency contracts. Meanwhile, 35 counties across southern, central, and southwestern England baked in temperatures that represented record highs for the date in several local observation records going back more than a century. At the very same moment that a gridder was crawling through a May blizzard near Barnard Castle in County Durham, a beach in Bournemouth was more crowded than most August afternoons. The contrast, captured in images that spread across social media within hours, was jarring in a way that weather maps alone cannot fully convey. But as startling as the images were, the science behind them is not mysterious. This kind of simultaneous extreme, cold and heat existing side by side across a small geographic area, is exactly what researchers studying climate whiplash have been predicting would become more common. Scientists have given this phenomenon a formal name. Climate whiplash describes rapid swings from one type of weather extreme to another, most commonly from persistent drought to persistent flood, from record warmth to unseasonable cold, or from one regional extreme to a simultaneously opposite extreme in a neighboring area. Globally, shorter-term whiplashes over the course of a few months have become roughly a third to two-thirds more frequent in recent decades. Year-to-year swings between opposite extremes have increased by up to a third. And in the UK, the driver behind almost all of these events is the same, the jet stream behaving in ways it did not used to behave. for a reason that climate scientists now understand with considerable confidence. The Arctic is warming faster than anywhere else on the planet. At the surface, it is heating up at more than twice the average global rate. This matters enormously to the jet stream, says, because the jet stream draws its energy from the temperature contrast between the cold polar regions and the warmer air of the mid-latitudes. When the poles were much colder relative to the equator than they are now, the jet stream was tighter, faster, and more disciplined. It flowed in a relatively straight band and moved weather systems through the UK and across Europe at a predictable pace. But as the Arctic warms and the temperature contrast between north and south weakens, the jet stream loses its rigidity. It slows down. It begins to meander in larger, more exaggerated waves, looping far north into Arctic regions and then plunging sharply southward. And when those waves become very large and very slow-moving, which they do more frequently now than they did 40 years ago, they can pin completely opposite air masses over neighboring parts of the same country for extended periods. The technical term for this is Rossby wave amplification. The plain language translation is that the atmospheric machinery that used to keep different air masses in their lanes is now allowing them to pile into each other in ways that produce exactly the kind of jarring, contradictory weather that the UK experienced in May 2026. This is not just a UK problem. The same jet stream disruption that put snow over Yorkshire and sunshine over Sussex has driven catastrophic weather events across the Northern Hemisphere. During the summer of 2025, an unusually southward displaced jet stream locked persistent storm systems over parts of the United States for weeks, producing catastrophic flooding in regions that were simultaneously baking in record heat just a short distance away. The same dynamics have produced unprecedented rainfall events across Central Europe, while nearby Mediterranean countries experienced their worst droughts in centuries, sometimes in the same week. The thread connecting all of these events is Britain's experience of climate whiplash has a specific and well-documented recent history. The year 2025 was officially the warmest summer on record for the UK, with mean summer temperatures surpassing all previous records. The summer of 2025 was, according to a Met Office attribution study, made 70 times more likely by human-caused greenhouse gas emissions. Then, from December 2025 through February 2026, the UK experienced one of its most relentlessly wet winters in living memory. Some locations in Devon and Cornwall recorded rain on 50 consecutive days. The University of Reading's official rain gauge recorded precipitation on 31 consecutive days, a run described as unprecedented in records stretching back to 1908. The jet stream sat further south than usual for weeks at a time, steering low-pressure system after low-pressure system toward the southwest of England, where they met blocking high pressure over Scandinavia and stalled, dumping their moisture in the same locations again and again in what some meteorologists informally called an occlusion graveyard, going from record warmth to relentless winter rain to a spring that produced simultaneous blizzards and beach days in the same country. This is what climate whiplash looks like across an entire seasonal cycle. The infrastructure implications of this kind of weather are significant and not well understood by the public. Roads and rail networks are designed to handle specific temperature ranges and weather loads. A network built to handle southern England's traditionally mild and winters is not engineered for sudden late-season heavy snowfall. Gridding resources are contracted and deployed on seasonal schedules. When snow arrives in May, those contracts have already been wound down. Emergency recalls cost significantly more than routine deployment. At the same time, the soil and drainage infrastructure in the north was already waterlogged from the preceding months of heavy rainfall, which meant that the sudden snowmelt after the May blizzard hit drainage systems that had no remaining capacity, producing localized flash flooding in areas that had been covered in snow only 48 hours earlier. The same system that brought the blizzard north and the heat south produced within a single week, conditions that stressed road networks, rail infrastructure, agricultural schedules, NHS emergency admissions, an energy grid demands simultaneously, at different points on the map and in different directions. The agricultural impact of May snow is particularly acute and often underreported. May is when livestock are typically moved to upland pastures after the winter. It is when lambing reaches its final stages on many northern farms. It is when the first planting windows of the growing season open. A sustained 24-hour blizzard across the Pennines and the North York Moors in mid-May disrupts all of these at once. Farmers who have already moved stock to summer pasture face emergency decisions about shelter and feed. Crops that have germinated in the warmer soil of early May are vulnerable to sudden deep freezes. Insurance claims for agricultural losses from unseasonal snow events have risen significantly in recent years, not because individual events are necessarily catastrophic, but because they are arriving outside the expected seasonal windows, catching farms at moments of maximum vulnerability. Meanwhile, in the south, The unseasonable warmth of 24 degrees in May was accelerating the growth of crops and plants at rates more typical of late June, advancing the agricultural calendar and creating a mismatch with supply chain schedules designed around average historical conditions. None of what happened on that May day in 2026 was, by itself, a climate record. The snow was heavy, but not the heaviest ever seen in May in the north of England. The heat was warm, but not the warmest ever recorded in May in the south. What was genuinely unusual was the simultaneity, the precision of the atmospheric setup that produced such extreme contrast across such a small geographic area, and the fact that events which would have been described as extraordinary 20 years ago are now arriving regularly enough that meteorologists and climate scientists are tracking not just individual extreme weather events, but the patterns between them, the whiplash rhythm of a climate system under increasing stress. The UK's Independent Climate Change Committee is due to publish its next major national risk assessment later in 2026, following a year of weather that moved faster between extremes than any comparable 12-month period on record. The question that report will have to address is no longer whether the UK's climate is changing. That question has been answered. The question now is whether the country's infrastructure, agriculture, the weather map for that 24-hour period in May 2026 looked like something produced to illustrate a textbook chapter on atmospheric extremes. Thick blue line where the cold Arctic air met the warm Mediterranean air, cutting diagonally across central England. Snow to the north of it, summer to the south of it. The line moved slowly over the course of the day, shifting a few counties one way and then back. And that single invisible atmospheric boundary, just a line on a computer model, was the difference between a winter storm and a beach holiday, between snowplows and sunscreen, between two versions of Britain existing at the same time, on the same small island, on the same warm Tuesday in May. There is something that the raw data and the weather warnings and the insurance claims do not quite capture about a day like this. Something that is harder to quantify, but just as real. For most of human history, the seasons were predictable enough that entire cultures built themselves around them. Planting calendars, grazing patterns, festival dates, building codes, clothing norms, all of these emerged from centuries of accumulated experience. About what weather arrived when. May meant one thing, February meant another. The language of the seasons gave people a framework for navigating the year. When May produces a 24-hour blizzard in the north and summer temperatures in the south simultaneously, that framework stops being reliable. It is not just an infrastructure problem or an agricultural problem or an emergency services problem. It is a deeper disorientation, a signal that the climate system that shaped how human beings in this part of the world organized their lives, their farms, their buildings, and their expectations is now operating outside the parameters that made all of that organization possible. The whiplash is not just atmospheric. It lands in the daily life of every person who looked out the window that Tuesday in May and genuinely could not believe what they were seeing.